Okay, in this video, we are going to dive deep into the relationship between a subject and a population. As you saw in our previous video, a population is pretty much a collection of subjects. And in Pumas, we can create subjects with the subject function. So I say that my S1, subject 1, is pretty much a subject. And this function, if you hover over the documentation, you see that we can use these to create subjects, and it takes those keyword arguments. So we have ID, observations, covariates, events, and time. So, for example, suppose I want to create a subject which has ID equals 1. Now, if I run this, I get back a subject. And I can also create whole populations out of this subject function. The way I do it is I need to create a vector of subjects. We can do this using standard Julia tools. If you want to learn more, I would highly recommend you to go over into our Julia Basics and Julia Functions videos in our tutorials. And okay, how we do it? There are two ways that we can do it. First one is what we call array literal. So this is similar to the list comprehension in Python, and this is our array comprehension. So we can say something like subject ID equals 5, or every I in 1 should van. So this gives us a population with 10 subjects. And if we index that population, we get back subject 1 and pop2 with subject 2. Another way that we can do this is we can use the map function in Julia, which takes a function as first position argument and a collection of things as a second position argument. So I'm going to use an anonymous function, which is pretty much a mapping. So I'm going to map I to subject, which ID equals I, and my list is going to be wanted bad. Now, if I run this, I get back the same result as in the array comprehension. So these are two ways that I can create subjects and populations in Pumas. Now, these subjects, they don't have an ID. They are empty, so they're not very much useful. We can try to create subjects which have a dosage. So, for example, we can use this dosage regimen SERP function in Pumas that creates a series of events. And by default, we can supply something like amount as position arguments and all of your no-man concepts like time, compartment, EVID, II, and additional dosage, range, and duration. So we can give all of those. So for example, here I'm giving 1,000 milligrams and the rate is 500. So I'm giving this over 2 hours at time equals 0 with 5 additional doses given every 24 hours. So that's pretty much our amount, our time, our IDL, II, and our rate. And if we run this, we get back a data frame with a single row, which is pretty much describing the event in a no-man formatted data set. And once we have defined this, we can create a subject. Let's call this subject 2, where we specify events equal EV. And of course, we give an IB to this subject, and ID equals 2 for now. So if we run this, we get a subject, and this subject, it has an event. And I can also take a look at this subject. I can convert this subject into a beta frame. And if I do this, I get back pretty much a no-man formatted data set with the events for that subject. So as you can see, these are all of the dosing rows for our subject. We can also combine events. So I can pretty much say EV June. It's pretty much the same dosage regimen, but now I'm giving just 500 milligrams at time equals 3 hours, for example. Now we can define this and we can create a new events combined, where we construct a dosage regimen by passing a vector of two events, two dosage regimens. So it's kind of a meta function. So we can combine those. And if we run this, we get back now either combine it and we create a new new subject. This is subject 3. So this is subject ID equals 3, and the events is if we combine it now. When we do this and we create a vector frame out of this construct, out of this subject, we have, as you can see in row 2, we have an additional dosing event. It's a single dose only of 500 at times equal 3. So this is how we can create more complex subjects. We can also do the same thing as we did here with the vector of population. That will also works. And finally, we can add covariates to our subjects. We can create a function called choose covariates. This is a short form assignment, as we call in Julia. I highly recommend you to take a look in our Julia's function video. So if I run this, I create a function, and just showcase, if I call this function choose covariates, I get back a different main tuple with weight equals 93, clearance equals 99. So, sorry, CRCL equals 99. So this is pretty much every time that I run this, if it will random uniformly from this interval and assign to the weight valued, and also we run from this interval and assign to the CRCL interval. So I can do the same as I did above. I can define a number of subjects. I can then create a population for simulations where I'm using the map function to map to create a vector of subjects, which is going to become a population. And I'm going to do this over 1 until n subjects. So this will go over 1 to 10. And take a look that we are saying that our events is the EV that we defined. Above, our observations is equal as a main tuple with dv, our dependent variable equals nothing, and our covariate is the output from choose covariates. Now, if we do this, if I define and subject correct, now if we do this, we get back a population. And if I call data frame into this population, we see that indeed we get back the random values for each of the subjects. So for example, subject 1 has weight 98 and CRCL 116, and subject 9 has weight 96 and CRCL 72, and subject 10 has different values also for weight and CRCL. Now we can play around in this choose covariates. We can use the Puma's distributions. So for example, I can create a new covariate called condition. And this condition is going to be a random of a Bernoulli variable, which probability of success P03. Now I define these new choose covariates. I run everything again. And as you can see, now we should have a new variable called condition, and this is a Boolean. I can pretty much convert this to integer if I want to by passing in the int function into that Boolean. And if I run this again, you see that our condition now it's an integer. So subject 1, 2, and 9, they don't have the condition, whereas subject 10 has the condition. So this can be used in a read Puma's poll into this data frame, and you can pass in the condition as a covariate along with the weight and the CRCL. So as you can see, subjects and populations, it's in Pumas allows for a very flexible workflow if you want to do simulations, or if you are going to start asking questions like the what if questions that you ask in a common PKPD workflow. What would happen if I had a subject like this? Then you can define your subject, You can pretty much simulate from your model with your parameters. And this subject, you can simulate what happens. And this is very powerful in Pulldoes.